Cigarettes may look like one of the simplest consumer products in the world, a small paper tube filled with shredded tobacco and sealed inside a cardboard pack. Yet behind every finished cigarette lies a massive, highly automated industrial process involving agriculture, chemistry, precision cutting, high-speed machinery, strict quality control, and global logistics. From harvested tobacco leaves drying in curing barns to ultra-fast cigarette makers producing thousands of units per minute, the modern cigarette industry operates with a level of engineering and scale few people ever witness. And today on the How Factory, we're going inside that system to see how cigarettes are made, tracing the journey from raw tobacco leaf all the way to the finished sealed pack, ready for distribution. What appears simple on the outside is actually the result of decades of industrial optimization and tightly controlled manufacturing. The process begins far from the factory floor in tobacco-growing regions around the world. Tobacco plants are cultivated on large farms under carefully managed conditions. Different varieties, such as Virginia, Burley, and Oriental, are grown for different flavor, burn, and aroma characteristics. Farmers monitor soil nutrients, rainfall, and plant health throughout the growing season. When the leaves reach maturity, they are harvested either by hand or by machine. The leaves are then cured, a crucial step that transforms fresh green leaves into usable tobacco. Curing methods vary by tobacco type. Flue curing uses heated barns to dry leaves quickly while preserving sugars. Air curing allows leaves to dry slowly in ventilated barns. Sun curing relies on natural sunlight, while fire curing exposes leaves to controlled smoke. During curing, moisture content drops dramatically and chemical changes occur that affect flavor, color, and combustion properties. Once cured, the tobacco leaves are bundled and transported to processing facilities. At these plants, the leaves are unloaded, inspected, and graded by size, color, and quality. Foreign material like stems, dust, or damaged leaves is removed. The tobacco is then conditioned, a process that reintroduces controlled moisture to make the leaves flexible enough for mechanical handling. Conditioning chambers carefully adjust humidity and temperature so the brittle dried leaves don't shatter during processing. After conditioning, the leaves move to primary processing. Large machines strip the central stem, known as the midrib, from each leaf. The stem contains less desirable material and burns differently than the leaf itself, so it's separated for other uses or disposal. The remaining leaf lamina is cut into smaller pieces and blended. Blending is one of the most important stages in cigarette manufacturing. Different tobacco types from different regions are mixed together according to precise formulas. These blends are designed to produce consistent taste, aroma, burn rate, and smoke characteristics. Industrial blenders resemble giant rotating drums or conveyor-based mixing systems that tumble tons of tobacco until the mixture is uniform. Even small variations in blend composition can alter the final product, so blending is tightly controlled and continuously monitored. Once blended, the tobacco enters the casing and flavoring stage. Contrary to popular belief, this step is not simply about taste. It also affects moisture retention, burn behavior, and smoke consistency. The tobacco is sprayed or misted with carefully measured solutions that may include water, sugars, humectants like glycerin, and flavor compounds. These solutions help keep the tobacco from drying out, ensure even burning, and stabilize the product over time. The treated tobacco then rests in conditioning silos, allowing the additive to distribute evenly throughout the leaf material. Next comes cutting, where large sheets and strips of tobacco are transformed into the fine shreds used inside cigarettes. High-speed cutters slice the tobacco into narrow strands called cut filler. The width and length of these strands are critical. If they're too fine, the cigarette burns too fast. Too coarse, and airflow is restricted. Laser sensors and vision systems measure strand size in real time, adjusting blade speed and spacing automatically. After cutting, the tobacco passes through dryers or coolers that fine-tune moisture content to precise targets, often within fractions of a percent. While the tobacco is being prepared, other parts of the cigarette are manufactured in parallel. Cigarette paper is produced from cellulose fibers and engineered to control burn rate, ash appearance, and smoke delivery. Some papers include microscopic perforations that dilute smoke with air during inhalation. Filters are made from cellulose acetate, a plastic-like material formed into long rods with thousands of tiny fibers. These fibers are bonded together and wrapped in plug wrap paper. The filter rods are cut into short segments sized to match individual cigarettes. Filter design, light including density and ventilation, plays a major role in draw resistance and smoke characteristics. Now comes the heart of the factory, the cigarette-making machines. These machines are among the fastest continuous manufacturing systems in the world. Prepared tobacco is fed into a forming section where it's evenly distributed onto a moving paper ribbon. The paper wraps around the tobacco, forming a continuous cigarette rod that's sealed with a thin line of adhesive. This rod can be produced at speeds exceeding 7,000 cigarettes per minute. Immediately after formation, the rod passes through cutting knives that slice it into precise lengths. At the same time, filter segments are aligned and attached. In many designs, 2 tobacco rods are joined to a double-length filter and then cut in half, creating 2 finished cigarettes in a single step. Adhesive systems bond the filter to the cigarette paper using tipping paper, the distinctive banded paper around the filter end. Cameras inspect alignment, length, and seal integrity at full speed. Any cigarette that fails inspection is automatically ejected. After formation, cigarettes move to conditioning chambers where temperature and humidity are stabilized. This prevents warping, cracking, or moisture loss before packaging. From there, they enter the packing line, another high-speed operation. Cigarettes are counted and arranged into precise groups, usually 20 per pack. Machines place them into foil liners designed to preserve freshness. The foil is folded and sealed tightly around the cigarettes, then inserted into printed cardboard packs. Each pack is glued shut, stamped with batch codes and tax markings, and inspected by vision systems to verify correct branding and warnings. Packs then move to cartoning machines that group multiple packs into cartons. Cartons are wrapped in clear film for tamper resistance and protection. From there, cartons are packed into cases and stacked on pallets by robotic systems. Throughout packaging, barcodes and tracking codes are applied, allowing every case to be traced back through the manufacturing process. This traceability is essential for regulatory compliance and quality assurance. Quality control runs continuously at every stage. Laboratories inside cigarette factories analyze tobacco moisture, blend composition, burn rate, paper permeability, filter ventilation, and draw resistance. Finished cigarettes are tested using smoking machines that simulate standardized puffing patterns. These machines measure parameters such as smoke volume, burn time, and consistency, not for consumer use but to ensure manufacturing stability and regulatory reporting. Visual inspections check paper seams, filter attachment, and pack integrity. Any deviation outside specification triggers immediate adjustments or halts production. Behind the scenes, environmental control is critical. Tobacco is highly sensitive to humidity and temperature. Factories maintain carefully controlled climates to prevent drying or mold growth. Air filtration systems capture tobacco dust, which is both a fire risk and a quality issue. Dust collection systems, explosion-proof motors, and strict housekeeping protocols keep operations safe. Logistics complete the journey. Finished cases are stored in climate-controlled warehouses before being distributed to regional centers. Transportation follows strict handling requirements to preserve product condition. Inventory systems manage shelf life, batch rotation, and regulatory documentation across borders. Because tobacco products are heavily regulated, factories maintain extensive records covering sourcing, processing, testing, and packaging. What makes cigarette manufacturing remarkable from an industrial perspective is its sheer speed and precision. A product made from agricultural leaves passes through curing, blending, chemical treatment, micron-level cutting, high-speed assembly, and automated packaging, all in a process refined to produce billions of identical units every year. The engineering challenges lie not just in making cigarettes, but in making them exactly the same, every time, at extraordinary scale. From a dry tobacco leaf harvested in a field to a sealed pack on a store shelf, the journey involves agriculture, chemistry, mechanical engineering, automation, and logistics working together in perfect synchronization. It's a process largely invisible to the public, yet it represents one of the most sophisticated examples of mass production in the modern world. And that is exactly how cigarettes are cured, blended, cut, formed, filtered, packaged, and prepared for distribution. A complex industrial system hidden behind one of the most familiar products on Earth. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the factories and systems behind everyday products.